Welcome back. A hugely important part of chemistry coming. Acid-base chemistry. Big part of chemistry, and it seems to leak into all other kinds of scientific discipline as well. Everyone wants you to know acid-base chemistry. Where do we find it? Obviously, we find it in a chemistry lab, but that's just the beginning. Acid-base chemistry is a huge part of food. It's a big part of digestion. Our stomach, of course, is filled with acid. When it gets upset and we get heartburn and indigestion, you normally take something to do something about that. That's acid-base chemistry too. Water treatment relies heavily on the acid-base properties of the water we're trying to treat. Wineries are also very careful about the acid-base properties of their products. Physiology, biology, and biochemistry, again, all tied up in acid-base chemistry, a big part of the sciences. So it's very important that we have some kind of awareness of what's going on with acid-base reactions. So what is an acid reaction? What is a base reaction? Well, this is one of those strange things in society. The term acid seems to be very well known in society. They're horrible things and you throw them onto something and they burn holes in it, which of course always raises the interesting question, well, if they burn everything, what do you keep them in? And of course the answer to that question lies in the true nature of acids and bases. An acid-base reaction is simply a type of chemical reaction. It will work with some substances and not with others. So you can store it in all kinds of things like glass and plastic, and it's perfectly safe. There's no reaction. Let's have a closer look then at exactly what's going on. When we're talking about acid-base reactions, we are going to talk about what we call Bronsted acids and bases, a particular class of acid and base. By this definition, an acid is what we call a proton donor, something that gives away protons. A base is something that accepts or takes protons. So for an acid-base reaction, you must have an acid, you must have a base. Someone's got to give, someone's got to take. If you don't have those two halves, nothing will happen. Let's go back to this key term though, proton donor or proton acceptor. What exactly do we mean when we say proton? To answer that question, I'm going to take you back quite a few topics. Take you back to this model of the atom here, way back in module 1. This atom, go through it for yourself. You know it's hydrogen, you can see the H. How many protons, neutrons, and electrons? I'm hoping you decided it has 1 proton, the atomic number in the bottom corner. I'm hoping you decided the number of neutrons was 0, because remember the number in the top left corner is the number of protons and neutrons. So if that number's only 1, and there's 1 proton, there are no neutrons. And of course, being the hydrogen element, there's also going to be 1 electron. So that H11 just has 1 proton and 1 electron. What about this one here? I've now got that same hydrogen, hydrogen 1, but now it's got a positive charge. How does it get that positive charge? The only way it can do that is if it's given away its electron. So I now have 1 proton, and that's it. No neutrons and no electrons. So when I say an acid-base reaction involves an acid giving a proton and a base taking a proton, what I'm really saying to you is an acid gives away H+, it gives away hydrogen ions. A base takes H+, takes those hydrogen ions. This is what we're talking about when we have an acid-base reaction. Give and take of hydrogen ions. So far so good? We're going to go into the lab shortly. We're going to look at a couple of examples together. It's difficult to visualize acid-base reactions without a little help. When people are talking about whether something is acidic or whether something is basic, they often talk about the pH scale, where people generally say if it has a pH of around 7, it's somewhat neutral, lower than 7, it's acidic, higher than 7, it's basic. But we're not actually going to be able to see or measure the pH in the lab very easily without going through a lot more training. So I'm going to do something a little bit simpler. We're going to use what we call a universal indicator. I'm adding just a few drops of a chemical to these different samples here, and depending on how acidic or basic that solution is, I get a different colour. So in the samples you can see that pinky red colour suggests that the solution is really quite acidic. The orange and the yellow suggest it's still acidic but getting towards neutral. The green colour in the middle, that means it's neutral. And as we get into our blues and then into the purples, the solution is getting more and more basic. So that's going to allow us to see the chemicals that we're working with in the lab and whether they're acidic, neutral or basic. So let's talk through an example together. We're going to start by talking about the reaction that I have on the screen here. We're going to talk about the reaction between HCl, more formally known as hydrochloric acid, and this one here, sodium hydroxide. As you can see by the colours I have in these two test tubes, The hydrochloric acid up here, that is an acid. We can tell by the pink substance there. It's got its hydrogen ion here that it's ready to give away if only someone will take it. And then over here in the purple, we have our base. The sodium hydroxide is a base. The big giveaway for us here, compounds that contain this ion here, the hydroxide anion, tend to be bases, tend to be quite good at being bases too. So I have an acid and I have a base. Let's now go into the lab and have a look at what happens when I mix these two together. So you can see I've got the two test tubes, my acid and my base. Just taking some of the acid and adding that to the base, and you can see that there is an immediate colour change. The resultant solution that I get is green in colour. If you remember the chart we looked at earlier, that green colour means the solution is now neutral. So back to our notes. Once again, we can see that our hydrochloric acid and sodium hydroxide have clearly reacted because there has been a change in colour, a change in how acidic or basic this solution is. What's happened here is that the hydrochloric acid has been a good acid and it's giving away its hydrogen ion, its H+. Where is it going? The sodium hydroxide, and in particular the hydroxide part, is being a good base. It's taking that hydrogen. I think you can see where this is going. If you've got OH and you add another H, you have H2O. You have water. And this is quite often a product that you get when you react an acid and a base. They neutralize one another, that is the term we use, and they produce water. I'm also thinking you're looking at my chemical reaction and saying, well, hang on, something doesn't add up here. I've got chloride ions and sodium ions left over. And sure enough, they just remain in solution, quite happy together. So when we complete our written reaction, we've got sodium chloride as our final product here. So this is an example of a typical acid-base reaction. And you'll find that more often than not, when you mix an acid, something like this, we're going to give away hydrogen, and a base that contains these hydroxide ions, your product will end up being water and a salt. A nice simple reaction like this. Let's have a look at a different type of base. So our second example, we're going to use hydrochloric acid again, the same acid, but this time instead of using a hydroxide for my base, we're going to use this one here. I'm going to use sodium carbonate. Carbonate acts as a base. It's very willing to take hydrogen ions as well. So back into the lab, you can see in this vial here, I have a solid powder. I have solid sodium carbonate. If I add a drop of universal indicator to that, we can do this reaction in one of two ways. We can do it by adding the acid to the solid powder, or we can add it to the solution. In either case, when we add our acid to our base, the first observation we see is a great plume of bubbles emanating from our solution. Very, very clear to see. Where are those bubbles coming from? Let's come back to our notes for a moment. Those bubbles must be coming from when our acid is reacting with our carbonate. And that's exactly what happens. Whenever you add an acid to a carbonate, you do get those bubbles. What the acid does is it breaks down the carbonate, and out of it we get carbon dioxide gas. That's all well and good. You're thinking, well, what about the hydrogen that we've added to it? If that base has taken the hydrogen, where does that end up? Much like our first example, when you add an acid and a base, you do end up also forming water. So our two key products here are the carbon dioxide gas, you can see. We form water, and once again, we've got our anion and cation left over, and they form a salt that we have left in solution. Right, so acid-base reactions, really all I come down to is donating a proton, donating H+, a hydrogen ion. Acid wants to give it away, base wants to take it. Seems like a simple concept in principle, but these reactions are immensely important in all the sciences.